Pandas is the world's most popular Python library used for everything from data manipulation to data analysis. So in this course, we started learning all about pandas in Python, the pandas data frame, and we've used it to extract, filter, and transform various real-world data sets. So welcome back to the channel and welcome back to Excel Island, where the goal and objective is to learn and master Python over the next 100 days. Today is day 26. So we actually started learning Python all the way from day 1 till day 26, which is today. And we are on the course called Data Manipulation with Pandas. We've covered other courses in this Python career track on the DataCamp platform. I think we're on the third or fourth course in the 9 courses in this Python career track. So we are on data manipulation in Pandas, which actually contain 4 chapters, and we are on the third chapter, which is slicing and dicing data frame, slicing and indexing data frame in Python using pandas. So we've covered quite a lot from the beginning of this data manipulation with pandas. We've actually looked at transforming data frames where we got introduced to how to perform fundamental manipulation, including sorting, subsetting, and adding new columns in Python using pandas. We also looked at aggregating data frames, which is summing statistics, your mean, max, mean, median, and so on that you're quite familiar with, which is just summary statistics in Python using pandas. And we actually looked at slicing and indexing, which is the chapter we are right now, where we learn how to combine, select certain columns, select certain rows, call on certain conditions, filter, sort, and do a whole lot of stuff. So you can catch all of this on the live stream tab on the channel when you go to the channel on the live stream tab. So also all the data sets we'll be using is already linked under the YouTube description. So do make sure to download the data sets and practice along with me. So on today's live stream, we'll be looking at the last a couple of last lesson on the third chapter of the course, which is pivoting in Python. You know, the normal pivot tables you are quite familiar with in Excel is a concept like similar to that in Python also. So we want to look at how to perform pivot analysis in pandas in Python using pandas. So do what to support the channel by giving this live stream a thumbs up or this video a thumbs up whenever you come across it. Hit that subscribe button and put on the notification bell so you'll be the first to know whenever I go live or drop a new content on the channel. So without further ado, my name is Sheriff. I'm a top rated plus freelancer on the Upwork platform. I'm a full-time freelancer. This is my work session. This is where I do my stuff all the way from home, and I'm trying to upskill myself for the year 2024. And this is the last tool I'm planning to learn this year. I hope to finish this before the end of the year, and I'll see you next year as we continue upskilling and growing and building projects also. Also, by the way, before I finish all this, I plan to share a couple of projects I've been working on. Hopefully, I get a whole lot of time to combine with what a lot of stuff I'm doing, a lot of projects I'm working on, trying to work and survive as a freelancer in Nigeria. So, without further ado, let's jump back to learning. And welcome to day 26 of our Python learning journey. So, we're actually using the DataCamp platform, as I said earlier. I'm actually subscribed to a 1 year subscription on the platform. If you are not aware, so I'm just going to continue from data manipulation with pandas. I'll just click on career track real quick. So we've done data analysis in SQL. We've done out of Power BI. So you can catch all of that on the live stream tab on the channel. We're actually on data analysis in Python, which we are just 28% out of 100%. So we've set a target of 100 days to complete this, let's say, this whole career track. So if I open it real quick, you can see we've done introduction to Python, intermediate Python, and we did our first project, which was the whole video investigating Netflix movies. You can go to the live stream tab. You're going to see this project there also. And we're on the fourth course, as I said earlier, our fourth course, which is data manipulation with pandas. And we've covered the first 2 chapters. We're on the third chapter. We have one more chapter to complete. And after that, we're moving to the next project, which is exploring NYC Public School test results course. So I hope to see you in this project. You can see we have a lot of courses. You can see Python is not really that complex. You just have to know a bunch of code. The content is not really that much compared to SQL and Power BI that we did earlier. So I'm just going to continue from here. Let me just put on my headset real quick here. Let's continue and complete this last chapter of the course. So I have my Jupyter notebook already launched here. You can see the first theory chapter that we covered. So let's move to indexing and slicing. So these are all the code we've written so far for this data manipulation with pandas. So these are the three sheets. So if you want me to share this Python file with you, this Jupyter notebook file, let me know in the comment section. If not, you can just follow along and write your own code from scratch also. And now we've done quite a lot so far. As you can see, slicing, we've done a lot of manipulation here. So I'm just going to continue from the lesson. So let's see how the recap works. Okay, just going to show me what I covered on the last lesson I did. Can see, so got it. Let's talk about working tables in Python.
You saw how to create pivot tables with pandas in Chapter 2. In this lesson, you'll perform subsetting and calculations on pivot tables. Here's a larger version of the dog dataset. The extra dogs mean we have something to compute on. Recall that you create a pivot table by calling .pivottable. The first argument is the column name containing the values to aggregate. The index argument lists the columns to group by and display in rows, and the columns argument lists the columns to group by and display in columns. We'll use the default aggregation function, which is mean. Pivot tables are just data frames with sorted indexes. That means that all the fun stuff you've learned so far in this chapter can be used on them. In particular, the loc and slicing combination is ideal for subsetting pivot tables, like so. The methods for calculating summary statistics on a data frame, such as mean, have an axis argument. The default value is index, which means calculate the statistic across rows. Here, the mean is calculated for each colour, that is, across the breeds. The behaviour is the same as if you hadn't specified the axis argument. To calculate a summary statistic for each row, that is, across the columns, you set axis to columns. Here the mean height is calculated for each breed, that is, across the colours. For most data frames, setting the axis argument doesn't make any sense, since you'll have different data types in each column. Pivot tables are a special case since every column contains the same data type. Time to play with pivot tables.
Okay, so let's say pivot tables. It can be a little bit tricky. Let's give it a shot. So you say pivot temperature by city and year. So this is our data set there that we are working with. Let me just run the code one more time. I'm always afraid to try something. There's something here called restart the kernel. Because I just opened this file when I was about to start the live stream. So the code, it may not see some variables. I need to run it from scratch. But I believe there's a way to run all of them at once. So let me just run it from scratch and see. Oh, let's start again. Okay, voila, can see now. Can see the code are working back. So because I was seeing it with calling on some previous variables. So it may decide that it is not seeing them. So that's I'm rerunning the codes one more time. Okay, I'm being careful because of errors like this, because I didn't sort out this error. Because see, I kind of tag it out that this returns an error or sort it out later. So I'm just going to add this back and move on. Okay. I think we are good to go. So I've run all my previous line of code back. So that if I call on any previous variable, it is going to see those variables or that variable. Voila, I think this was the last code we ran from the previous live stream. So if I read the instruction, I say it is interesting to see how temperatures for each city change over time. So looking at every month's results in a big table, which can be tricky to reason about, instead let's look at how temperatures change per year. So you can access the component of the data year, month, and day using the code from data frame column dot dt component. For example, the month component is data frame column dt dot month, and the year component is data frame column dt dot year. So this line of code can be used to access a component of a date. Okay. Once you have the year column, you can create a pivot table with the data aggregated by the city and year, which you explore in the coming exercises. Okay, let's see that. Pandas is loaded as PD. Temperature is available. You see, we're actually using the raw temperature that we got connected to earlier, not the one that we have actually manipulated. So this is the raw temperature data sets without any manipulation. But some of these we have manipulated it. You can see I kind of set the index. Instead of the index should be 0, 1, 2, 3, I made the city the index here. So I have actually manipulated this temperature underscore index. So I'm going to make use of the raw temp from the beginning of the code. So let's move down and see. So if I say add a year column to temperature from the year component of the dates column. Okay. So what I'm going to do now, I want to add a new column to an existing table. So this is how we're going to do it. Mm, Actually, the mistake I did was each section in a chapter, I'm supposed to have written a code. I'm starting another concept at that edge. So let me just call on the temperature. So this raw data here. So this raw data here, this is the raw data, which is this file here. This temperature CSV file here, which is already linked under the YouTube description. So make sure to download and practice also. So we want to add a new column by extracting the year from this date column. This is what I want to do now. Let's see how to do that. So add the year column to temperatures. Okay. And it says to add the year column, you mention the data frame, the column, then dt dot year. So let's do that. So I always love doing it first in my Jupyter notebook before giving it a shot right here. So this is the code for that. I'm just going to copy this line of code. So the data frame is temp. Mine is temp. Our data frame is temp. The column we want to extract is the dates column. I want to extract the year. Let's go in, let's see if it works. Oh, we got an error. There's something I'm missing. So data frame. And then I need to mention the data frame back again, yeah? Temp. Let me see what the error means here. Oh, I hope I'm not mistaken. Wow. So I'm missing something. So if I continue with the DT here, let's see. DT, what does the DT means? So I'm getting this error. It says can only use the DT accessor with dates like value. So it's not seeing this as a date. Why? Oh, why is not seeing this column as a date? That's a big error there. So, but let me try it out. Dot components. Dot components. Okay, the component I want to extract is the year, which is mentioned there. Why can't I access this? Let me see if I'm going to get same error in this case here. Let's see. Or you can see that it's worked. It's worked here. Add a year column to temperatures. Temperatures DC dot here. Oh, why is mine not now working? I need to troubleshoot it. If I'm troubleshooting it on the live stream is going to take quite a lot of time because I have no idea what this error means. I have to troubleshoot it with an AI, definitely probably a ChatGPT or something. Okay, okay, let's continue from here first. Let me see if I can get this line of code. It says pivot average temperature by country and city versus year. See the results. So add the year column to temperature from the year component of the date column. It says make a pivot table of the average temperature column with country and city as rows and year as columns. Assign to temperature. I want to assign it to this temperature sheet here. Okay, let's see and look at the results. Ooh, okay, I want to say temperature dot pivot table. I'm not happy that my open and close the bracket first. I'm hoping I could troubleshoot this right away. Let me see. I have my chat GPT here somewhere. Okay, just hold up a minute. Let me bring up my chat GPT. Wait, quick here. I wish to troubleshoot that error now so that I can practice. Uh, mm, sometimes I'm trying to launch my chat GPT. Or sometimes it just goes, you get into an error and you have no idea about. But figuring out a way to troubleshoot is always interesting. Come on, my chat GPT is taking time to load. Come on. So I think I understand this error. It's saying can only use .date year assessor with date time like values. Probably that means this is my column. It's not seeing that column. The data type is not date. And I think I checked the data type for this here. We are checking the data type info, the date column. Mm, the data type is object, you can see. The data type it is seen is objects. So the mistake was that formatting, I could have formatted the CSV file like a date type before actually connecting to it in Python. Yeah, so the data type is object rather than date. You can see this one is integer, float, object, object. Why? Why is data type object? Why? Why? Well, let me just ask ChatGPT how to extract our dates from a date column object data type. That could actually solve the problem. Let's see if we can troubleshoot this on the live stream. Okay, let me just start a new chat real quick. We have a ChatGPT launched already. So I could just say, oh, hello ChatGPT. Let me just give it ChatGPT something simple. So I am trying to extract the year from a dates column in Python using pandas, using this pandas code, using this code. Let me just copy the code. Just copy the code. This panda code, and I am getting this error. Let's copy this error. I'm getting this error. I'll just ask you to provide me an alternative rather than trying to troubleshoot that error. Can you explain what the error is and provide an alternative code? Let's see. Oh, come on. I said it. So that column is not formatted as a dates column. So another method I could have used is, okay, let's see. Okay. Okay, let's see. Alternative code. You need to convert the column to a datetime format using PD to datetime before applying the date access. Oh, interesting. Okay. Okay. Convert explanation. Convert to datetime. PD to datetime. Temp dates. Convert the values in the date column to datetime objects. Then access the year. I think that would be better. You can convert it to a date. If your data still have issues, ensure there is no invalid date format by checking with print temp.date. I think let's format that. Convert date column to date time. So let's convert the date column to date time. Okay, I think I prefer this method. Let's convert the date column to date time first. Let's see. So if I convert this PD dot to date time to date, let's see. Voila, it works. So now let's column temp dot edge this time around. I need to check whether the dates type have changed from object to dates. We just do temp dot info. Let's see. Ooh, we can see now. You can see the difference now. The dates column is not changed to dates type. Interesting. Initially, when we connected to the raw data without converting that, the data type is objects. Voila. So we solved it. Thank you, ChatGPT, for that. So we use that code to convert that column to a date type. Then if I now use this initial code I wanted to use that worked here, this code, let's see it now in action. Mine is temp. We shouldn't get that error again. Voila, now it worked fine. So that's how you troubleshoot sometimes. That's how I troubleshoot most of the challenge in data analysis. Mind you, my ChatGPT is premium. So that's why it was this. Sometimes the free version works fine also. I've used the free version a whole lot of times to write it. I just want to show you some of the prompts I've worked with within ChatGPT. So the most important thing is understanding the line of code, having a good basic knowledge of Python, Excel, Power BI, SQL before you can actually be using this AI to help you troubleshoot some issues. Because if you're using it without any knowledge, I could actually read, at least I could read the first. I know it is important in the pandas library here. I know what this line of code is doing. I know what this line of code is doing. I know what this line of code is doing. So that's very important to know. So let's move on. We solved that challenge pretty well there. Okay. So the next is to convert this to a pivot table. It now says make a pivot table of the average temperature column. This I want to make a pivot table out of this average temperature column, this column. Okay. Then as goes, we're going to have country as cities. The country and city is going to be by rows. We're going to have the average temperature for each country and city, and year as columns. So on the year will now be our column. So we're going to see the average temperatures for each country and city by year, for each country and city by rows, and for each country and city by rows, and the years by column. We have the average temperature in the rows in the value section. So let's give this a shot. First year, so I'm going to say temperature by country, city versus year. So I'm going to mention the data frame dot pivot table. It should be underscore pivot table. Then our column is going to be, our row column is going to be city and row. So then how do we mention two columns at once? Let's see. So it's going to be country, country, let me see, and city, then comma, the index, oh no, not here, the index and year as column. So the index is going to be our average temperature. Mm, no, the index is supposed to be, so our calculation here, my bad, sorry about this. So our value section is going to be the average temperature AVG underscore temp underscore C. So our index is going to be the row section, which is the country and city. I think I need to put this in back because I'm making use of two indexes. Let's see. Country, comma, city. Then the column section, comma, the column is going to be the year column. Equals to year. Okay, let's see if this makes sense. Let me even try to run the code. Let me try to run the code here and see. Oh, we run into an error. See? Now I need to figure the error out first. But let's try it here first. But initially, let me look at this. These temperatures, the dates. Okay. So if I run this code here, I'm expecting to get an error also. That's by the way. But this my temperature is going to be temp. Okay. Let's see. We can see the year key is error here. I don't think we've added this our year. We've not actually added it to this our data frame here. Let me check first. Let me check. Let me call on temp dot head and see. Because that it hasn't been added. I think we actually just extracted it. Add the year column to temperatures. We haven't added the year column from to it. It is not actually added. I don't know what we did there. Probably we just extracted it out from this dates column. But let's get help with this our int here. Okay, we are now actually assigning that extracted year column in the temperature data frame. As a result, when you later try to create the pivot table using the year column, it doesn't exist, leading to error. So we need to attach it. Okay. Temperature year equals to O. Okay. So this is where I'm supposed to attach it to the year column. Okay. Okay, this was my mistake here. View temperatures here equals to temperatures date. Okay. Aha, I can see it's worked fine now. So I need to correct this part of the code here. Let's see. So I knew I haven't assigned it yet. Where is that? It is here. But mine is going to be temp here. So this is for us to add a new column to an existing data frame. We want to add the year column to this data frame. We've added it. So if I call on this data frame now, let's see. We should have the year column here. You can see now we have the year column. You can see we've added a new column, temp year, adding the year column to the temp data frame. So to do that, we're going to use this line of code. Yeah. So if I run on this code now, let's see. Voila. Okay. So the code ran successfully. So I need to call on this data frame called temperature associate. This variable rather. Let's call dot head. Let's say dot head. I don't even know say dot head. Let's see the data frame first. Of all I can see. I can see the year in the columns. The year will now be the column, while our country and city will be on the rows. You can see index is the country and city. But let's look at the first 5 rows. Let's look at that. Okay. However, like I see, we have a whole lot of data here. So this is average temperature by country and city for each year. Interesting. That's we just did a pivot table there. And this, let me look at this total record that we have here. Look at the total record that we have here. We just have just over 100 rows of data by 14 column. The initial data set here, this is our initial, is over 10,000 rows of data. You can see over 16,000 rows of data, and we have pivot those results into 100 rows of data and 14 columns. Looking at just one calculation though. So I'm looking at just one calculation. Dot head here. Dot head. And let me just say dot head here. Just to make the line of to see just few rows of data here. Interesting. Let's submit the code. Powerful pivoting. Now you have the pivot table. Let's manipulate it. So from this pivot table, you can actually manipulate the whole data sets. Interesting. Let's see. Okay, we have two more challenges to go. So it says subsetting pivot tables. So a pivot table is just a data frame with sorted indexes. So the technique you have learned already can be used to subset them. In particular, the lock plus slicing combination is often helpful. So we learned all about lock and iLock from previous live streams. So which is slicing and subsetting with lock and iLock. So if you really want to understand what lock and iLock is, I encourage you to go and watch the previous live stream to understand the concepts behind lock and iLock. But let me show you a couple of examples. So pandas is loaded as PD. Temperature by country versus year is available. It now says subset for Egypt to India. So use lock on temperature by country, city versus year to take subsets. So we just want to take rows of data from Egypt to India. So from Egypt, Cairo to India and Delhi. So from Egypt, Cairo to India, Delhi, and 2005 to 2010. So I need to go back to my previous line of code to refresh my knowledge. I'll just launch. Okay, this should be, it should be here. Let's see. This slicing and dicing. You can see we are using lock here to slice and dice here. You can see. Oh, let me see. Subset in both direction at once. Can see. So these are with subsets using lock. Okay, so let's give it a shot. So the first instruction says use lock on a temperature to subset from Egypt to India. So let's see. Let me see that. Subset from Egypt to India. So we want to return the rows for Egypt and India. Let's see. Let us do two subsetting. Let us look at this. Dot log. Okay, Egypt to India. Let's see it in action. So it's going to be this. This is our line of code here that we've pivoted. So this time it's going to be Egypt to India. Let's see. You can see. So it's going to show me the record for go for Egypt, for and everything other thing under India. So from Egypt, then from Egypt to Ethiopia, all the old records that are below Egypt, all the way to India. You can see it here. So this is what we have here. So these are the average temperature for them. So the next one now says, let me just copy this line of code here also. I'll make use of it here. It says subset for Egypt, Cairo to India and Delhi. So we want to subset two different rows. That means from Egypt to Delhi and from Cairo to India. So the line of code is, an example is here. Let me just copy this real quick. This subsetting is kind of tricky though, but I'm going to show you how it works. This is how you're going to do that. You can see here. So this is an example here. So from India to this, from India to Hyderabad to Iraq and Baghdad. This is a similar scenario here that we did here. Let's see those subsetting. So it's going to be this line of code. These are variable for this temperature, our pivoted variable dot log. It's going to be from Egypt to Cairo, then India to Delhi. Egypt here, to Cairo, then India to Delhi. You can see, I can see Egypt to Cairo. You can see I'm going from the country to the city. Then it's going to go from the country to the city, and then every other record that is under it. So from Egypt, actually going from Egypt to India. We're going to pick the Egypt and the Cairo. You can see, let me go for, we can see under Egypt we have Alexandria, but we ignore Alexandria this time around. So starting from Egypt, then to the inner level, Cairo. Then you can see up from Cairo, it took this Giza, from Ethiopia, Addis Ababa, and Abeba. You can see as Ethiopia, we only have Addis Ababa. I think this is Addis Ababa and Abeba. This is Addis Ababa. I think probably I don't know the city in this city in Ethiopia. Then for France, you can see it pick France and Paris, then Germany. It pick all every other thing, but we stop at India, Delhi. You can see in India we have more city in India. We actually stopped at Delhi here. You can see. So we ignored the rest of the city under India. So this is what this line of code is doing. I'm just going to copy this line of code real quick and make use of it here also. Now we want to go further. Subset for Egypt, Cairo to India and Delhi, and 2005 to 2010. So we want to select, go to rows and column. So how do you do that? Oh, let's see if I still remember how to include the rows and column. An example should be there that I've done earlier. Let's see. So the subset for, okay, let me see. Let me just copy this line of code. So the subset from Cairo to India, Egypt to Cairo, Egypt to Cairo, then India to Delhi. I want to add the column. I want to subset the column also and return few number of columns. Okay, let me see. I think I have something similar to this here. Nope. So these are you mentioned, can see. Then you mention the column you want. You mention the date. Okay, this is it here. So comma, the columns in double quotes. So let's see. Dimension, comma. Then the columns, I want 2005, double quotes, to 2010, 2010, double quotes. Let's run that line of code. You can see, and we return very few number of columns. Interesting. That's why it's good to keep track of your notebooks and remember what you did earlier in those previous line of code. Can always go back to them real quick. If I submit this, let's see. Submitted, and let's run the whole line of code. But like as we have same results, you can see that is how you use pandas to manipulate your data sets and have amazing results here. Let's run the line of code. Cool, we nailed it. So super pivot table subsetting. Slicing is especially helpful for subsetting pivot tables. Interesting. Oh, don't mind this. I've been learning outside live streaming just to implement some of the knowledge and practice. So this is why you're seeing this. I'm actually live streaming. So I've been live streaming for the past 26 days. So I think let's solve the last challenge and complete this slicing and dicing. It only took us almost 4 live streams to complete this part of the course because it is actually very technical and complex. You don't want to rush it. You have to have a good understanding of what you're actually doing here. Let's calculating on the pivot table. So finally, it says calculating on the pivot table. It says pivot tables are filled with summary statistics, but they are only a first step to finding something insightful. Often, you will need to perform further calculations on them. A common thing to do is to find the rows or columns where the highest or lowest value occurs. Recall from chapter 1 that you can easily subset a series or data frame to find rows of interest using a logical condition inside a square bracket. For example, series greater than the value you want to find about. So pandas is loaded as PD and the data frame temperature by country by city versus year is available. The dot head for this data frame is shown below with only a few of the year columns displayed. Okay, so the instruction now says calculate the mean temperature for each year, assigning to mean temperature by year. Calculate the mean temperature for each year. For each year, hmm, how do you do that? So get the worldwide mean temperature by year. So let's see how to do that. Let's figure it out. So get the worldwide mean. Okay. Calculate the mean temperature for each year, assigned to mean temp by year. You can see mean temperature by year, temperature by country by city variable dots mean. I think that should be dots mean. Let me see if I still remember this. That what we did on chapter 2, summary statistics, and I'm supposed to remember. Let's see. Mean I'm supposed to remember. Let's see. Let me open my aggregating data frame of Pandas notebook. Print the median. Okay, you can see the mean, median. The mean, I said it does mean. Sales weekly sales does mean. Interesting. Let's see. You can see that's the mean temperature. If I call on mean temperature now, but it says by year. So I'm missing something. I only calculated the mean. Okay, let's see. You can see by year. Interesting. We pick the year, and this is the mean temperature for each year. But what I'm confused about is that why did they pick only the year from year until they calculated the mean temperature? I need to understand how it did that. This may be correct, but having an understanding of how that happened or occur is very important. But let me see first. Because for the year, this is the mean temperature. Mm. Is it because this is the only variable here? The only integer here? Why did they pick the mean instead of picking the country, city, and dates? Why? How did it pick that? Let me see. Let me copy this real quick. Let's see. Now says filter for the year that are the highest mean temperature. Print mean temperature. Okay. Can also use series greater than the value. Okay. Says filter for the year that are the highest mean temperature. If I'm to do that, I can just say mean temperature. Okay, going to be mm, I need to understand something. Filter for the year. There's a way you filter. Let me see, how do we filter? There's a way you filter. Let me go back to look for the word filter. I think we're going to figure it out. Okay, let's see how to figure this out. Hold up. Let me do something. Oh, am I getting error here? I shouldn't be getting error there. I can't do like this. I was hoping I could do something here. I guess I can't do that here also. Let me just run this line of code, okay? Okay, okay. So let me give it a shot then. If I run into an error, I could find a way to filter for the year that had the highest mean temperature. So to do that, it says you call from Chatan that you can easily subset a series of data frame to find rows of interest using a logical condition inside the square bracket. For example, series. Okay, so let me look at chapter 1 real quick for this knowledge. Okay. See the way you filter here. See? You want to filter for rows where individuals is greater than this. So you mention the column you want to filter on greater than. Interesting. So we found it. So it's supposed to be the series. So we want to filter for year greater than this year. Okay. Greater than the mean temperature. Okay. Figure it out. So okay. Let me give it a shot here first. Uh Filter for the year that had the highest mean temperature. Then how do you do that? The series. Okay, this is here. Mm, homelessness. Mean temperature by year. Hold up. So I'm confused. Yes, I'm going to type the bunch of code first. Let me see. The data frame. I'm going to mention the data frame and the column. So data frame is temp, then greater than the mean temperature by year. So let me see if this is going to work. Let's see. I'm going to get rid of the print. So mean temperature by year greater than this. Let's see. Error. So I didn't index it. I didn't index it very well. Let me see the way to index it here. Okay. So I didn't index that very well. Hmm. So I want to filter for this. Let me see. So what am I missing? I'm missing something here. I'm missing something here. So I didn't index that very well. Let's see though. Okay, let me run this. Let me just run this and see the error I'm going to get. Aha. As I'm getting same error. So let me get help on this error. The error comes from the code mean temperature. So to fix this issue, you should compare mean by year to its maximum value directly like this. Okay. Dot maximum. Oh. It says mean temperature in brackets, same thing, versus this is equal to the maximum value. Oh, let's see. So I should have one square bracket here to its maximum value, saying is this mean temperature equal to the mean temperature dot maximum. Let me see now. Aha, interesting. So you figure it out. Even though we had some help. Let's see it now. So I'm going to get rid of this print. Aha. Now let's see. But which year is it? Is it comparing with? Year 2013. So mean temperature equals to the temperature dot maximum. 2013 is the highest. It's definitely, is it comparing this to each other? Let's go on first and see. So get the mean temperature by city. Mean temperature by city. Temperature by country, city versus year. Okay. Mm. Sometimes it gets stuck like this. You have to start thinking of how to solve it. Get the mean temperature by city. Mean temperature by city equals to temperature mean, right? But by what? By set by city. How do you add city to it? This time around it was using year. In this case, by year. And I didn't mention any year. I just mentioned, oh, okay. Okay, let me look at something. This aggregating. Let's look at how we calculated the mean here. Do they add any values to it? We're looking at the mean here. This is just one record, one result was given out. Mean we didn't add by any column to it. Did we have any column to it? Oh, probably they're asking us to do pivoting. Ooh, look at my mistake. Look at my silly mistake. I think I figured out my mistake. In this case, we are told to what? Calculate. Let me go back here. It says get the worldwide mean temperature by year. So I'm expected to use pivot table in this case. I'm expected to use pivot table in this case. But what if, how do I not mention what I'm trying to do? Look at what we did here. Look at what we did here. We said here, average temperature. We didn't even mention the calculation it should calculate. How did we get to calculate by year, the average for it? We have no idea. So let me just go ahead with this then. It says get the mean temperature by city. The mean temperature by city. Let me see. Oh, I figured it out. The axis argument. Oh, so filter get the worldwide mean temperature by year. So this is wrong somewhere. Why am I wrong here? Let me see. So when I say dot mean, I'm supposed to mention the axis, which that is the year. Okay. Across column. So I didn't get the summing statistics across column. Okay, so we want to let's calculate the mean. So my axis here should be my year equals to year. So this is the right calculation I needed to do initially when I was doing this. So this was wrong here. So the axis is going to be by year. So let's give it a shot another time, another try. Let's see now. Aha. So there's an error somewhere. So my error is from this second line of code here. But let's see this one in action first. Okay. So this one calculates the calculation across column. So this is going to be, So the axis I'm using to calculate is the year axis here. For this pivoted table, temperature by country, city versus year. So let's see it now in action. Oh, what's my error again now? No axis named year. What's my year named here? Hmm. Why you not seeing my axis named here? Why? Is it the same error I'm getting here? But which variable should I use? Am I using the wrong variable? So same thing, no axis named here. How come? When I have a year calculation here, look at the year column here. Country, city. Okay, let me see the error here. Let me get up on this error. You should use axis one. Oh, I'm supposed to use axis one rather than axis here. Since this is the axis of one here, of course the column. Okay, let's say axis one now. Okay. Ah, same error. Wow, this is not good. Look at the year column here. We only have one axis, one column here in the first place self. This is a column. Well, let me now see if it's going to work in this case here. Axis one. No axis named one. Okay, good. Okay, what am I now going to say now? Oh, I should have put it in double quotes. It's supposed to be in double quotes. Okay, that's my mistake. I need the default axis. It's not supposed to be in double quotes. Ah, you see. So that was my mistake here. Now you can see the results. It showed me the results by country, by city. But I don't want the results like this. How do I get the results in a better way? But there should be a better way though. Let's continue though. By year. So axis one is the year. So we have the country, city, and the average temperature for each country and city. What about the country that have more cities? United States can see. Oh, interesting. Now we figure it out. That's good. Now let's run this line of code again. Okay, so I'm going to print it here. So filter for the year that had the highest temperature, highest mean temperature. Okay. Let me now run this two line of code. Because if this year that has the highest mean temperature, if I run it, if I run the same line of code here, we're going to have the same thing. Because it's Sudan. So this is the country and city that have the highest mean temperature compared to this, which you can see here. It's just 100 rows of data. It's only showing us just one. So filter for the year that had the highest mean temperature. So we're going to, so we are filtering against, so the mean temperature dot the maximum mean temperature. Okay, so this is the maximum here. If I want this line of code, does this one, does this line of code, I should get the maximum temperature. That's it. So this is the maximum. But I want to see the country, city, and the results. That's why we use this mean temperature equals to mean temperature dot maximum. Okay, interesting. So now the next line of code now says, next instruction now says, calculate the mean temperature for each city across columns, assigning to mean temperature. Get the mean temperature by city. Now by city, not by column. So I want to use not by city. Ooh. So instead of using axis of one that we use there, which is by column, we want to use by rows, which is by city. So how do we do that? How do we do that? So if I mention that, it should detect that I'm mentioning the row. I'm referring to the row, not the column. Let's do the same thing here. Let's see. Get the mean temperature by city. Okay. By city this time around, not by. So our axis is going to be city. Let's see if this is going to work. Let's see. Oh, no axis name city for object data frame. Why? You can see now. So there's no way for me to know if I'm mentioning the row or mentioning the column. But pivoting should be across the columns. Let's see. Hmm. Since I need to mention it another way. Okay. There's no way to calculate across rows, it's across columns. But let me feed it in here also. So get the mean temperature by city. So mean temperature by city equals to temperature by country versus here dots. You can see dots mean. So if I mention the axis should be equal to city. Let's see if we are going to get an error. Because no data frame name city. So let's see the error that we are going to get here. Same axis one. Okay, accept 0 for rows and 1 for columns. Since you want to calculate mean temperature for each city across the columns, you should use axis 1. But if it accepts 0 for rows, the axis parameter accepts 0 for rows and 1 for columns. Okay, it says accept 0 for rows. So for rows now, we have country as 0, city. What if I now use, let's use 0 here rather than city then. If I use 0 here, let's see. Not by year, then we want to say by year. So the mean temperature should be by city. By city. Let's call on the city data frame. You see it says 0 for rows. Let's see now. See 0 there. This should be the first 0 should be country. Because it's speaking year. But I don't want the year. I don't want the year. Same thing we did here. So it's speaking year as the axis. You can see. This 0. But we don't want 0, we want city. Let me see. Let me change it to city. Oh, why this last challenge is hard like this? This is the last part for this pivoting. So let's get up on the challenge. Say the axis parameter accepts 0 for rows and 1 for columns. Since you want to calculate the mean temperature for each city across the columns, you should use axis 1. But the challenge we have there is that the city is not across the column, it's down the rows. So how do we mention this? How do we agree by this that is not part of the column? That's a challenge now. Come on. This is wrong. That question is absolutely wrong. I say want to check the answer, though, but don't let us check the answer yet. Let's try to solve it ourselves. Say the axis parameter accepts 0 for rows and 1 for columns. Should we ask ChatGPT? I think we should just ask ChatGPT this time around. Okay, so what I'm going to do is just uh no, this is not it. Let me just copy part of the actual data frame. This is this part of it here. Let's see. Okay, let's start ChatGPT this time around. Ooh, because I just pasted it roughly there, which is not going to work. So the error is from the DataCamp team. But let's look at the results first. Okay, let's see. Let's take a int. No, this is not the int we want. The int for this second part. No way. Can see for the by city, look at the solution. What is the columns? This is totally wrong. Axis equals to columns. No way. Can see the column part there is absolutely wrong. So let me to mention the columns. I want me to calculate by city. City is part. Get the mean temperature by city. Okay, it says columns here. Let me just copy this part of the code and paste it here though. Oh, so it's going to do it by all the columns. So axis equals to columns. Interesting. So in this case here, we are exactly having the same results here. Country, city. Same thing we did, the axis is 1. So it's showing me but this time around it's showing us by country and city. We only want to get it by city. But it's still the same result we are getting by city because this city is, if I use 1 also here, just like we used 1 initially here, axis equals to 1. Oh, I think I now understand it better. Yeah, by 1. Okay, let's see. We still have same results. This is by city, but we still mentioned 1. But if you like it, country for each city, you can see city, 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 city. You cannot filter. Oh, that was my mistake there. Interesting, interesting take here. Interesting take here. That was quite challenging though. That was quite challenging. So I have similar results here, but I wasn't paying attention. So it is showing me the result by city, country, then it is mentioning the city. So same thing, if I just mention columns here, column will still work here. Columns should still give us the result. But it's only one column that is there, so we still have same results. Okay, now let's go back here. Just copy this line of code. Then for this, we have this. So for this city, we're having the same result also. Same thing here. Even one is going to work. Rather mentioning columns there. If I say filter for the city that has the lowest mean temperature. So the filter for the city that has the lowest mean temperature. So how do we do that? Filter for the city that has the lowest mean temperature, minimum temperature by city. So how do we filter this? It's just the same line of code though. The minimum, okay. Instead of maximum, it's going to be minimum here. Let's see. It's going to be minimum here. Mean. So we're going to get the minimum result there. Let me see it here. So it's going to give us the result for the minimum. Let's see. Ooh. Mean temperature and mean temperature. The minimum. What's the minimum here? Let me run the results here. As we get same result now. So what's not a problem? Yeah. So just filter for the city. That's the minimum temperature. The filter will say that's the minimum temperature. Let's see. Okay. Ooh, why am I getting an error? Index of Boolean series and of the index of the do not match. Why? Let me see if I'm correct here. Oh, did you use dot mean? Oh, filter for this is that the lowest mean, not minimum. Okay, mean. It does mean, not okay, interesting. Says dot mean, not minimum. Ooh, I'm still getting this error. Why am I getting this error here? How did you do this? We did it like this. Temperature, minimum temperature. What am I missing? Why am I getting an error here? Let's submit this. Oh, let's get help on this. Check the axis parameter when calculating the minimum temperature by year. But why are we stuck on the final challenge now? On the final aspect here. Okay. I think I'm still stuck here. Of course, yes. For axis. Okay, no axis needed for this. Oh. Yes. So good. 'Cause I face same similar challenges. The uneligible Boolean series. Let me now see what this means. Okay. It says print mean. You should use mean temperature by city. When I mean temperature, I'm supposed to be using by city, not by year. Oh, imagine. So mean temperature by city. This is what I'm supposed to use. Filter for the city that had the lowest mean temperature, not the year. Mean temperature by city for the mean, not the year. Let's copy this. So I'm not filtering for the correct. So filter for the city that has the lowest mean. So mean temperature by city. This is the mean temperature by city we are using, not the one that has this default 0 here, which is this one here. This also be 0 safe. This gets worldwide mean. It does also have any axis initially safe. But I didn't put axis initially in the first place when I did it earlier. You can see. And I put axis by 1. Even that is the default axis because that is the only axis we have here. The year column. Let me now run it again. As I have results here. When we filter for the highest mean temperature, that the highest mean temperature, we still have same results. Interesting. But so we mentioned the columns. If I run this now, I have this different results. Exactly. The result is quite different from each other. Okay. So now this is supposed to be mean, not by mean temperature by year. Okay, so that was my mistake there. Voila. The series is empty. This is empty. So filter for the city that has the lowest mean temperature. There's no result for it. Interesting. So there was no city that has the lowest mean temperature. There was none. Hold up a minute. Can see empty. Wow, interesting. Ooh, lowest mean temperature. Mean. I also use mean or mean. Lowest mean. Let's see. I used mean earlier. Oh, you can see. This is the minimum, not the highest. So in this case, now it's supposed to be minimum, not the mean. You can see. So China has the lowest mean temperature. This country, China, and the city have been 4.0. Is that correct? Same thing I have here. Like I see, countries. Country is China. Cities have been for the year. Because these are the other results. So this is kind of highly technical, and it took time. Ooh. It took an extra 30 minutes to figure out this pivoting and non-pivoting by columns. So the challenge was from this initial pivoting. It was quite straightforward. Just mention the pivot table data frame here. Where is that? Where we started from here. We pivoted the data from here. This was it. Pivot table, you mentioned the column and the number of columns you want to pivot by. Then the columns you want to pivot by the rows, then column by year. So next is now manipulating the actual pivoted data by columns. That's why you need to understand the axis arguments here. You need to mention the axis argument while trying to manipulate its axis, columns. Default axis is 0, and default axis is not 0. Oh, that was quite a lot of challenge. Interesting. So we've completed this part, chapter 3. So I'm moving to visualizing your data with Panda. This is quite much too. So we'll probably be spending probably 3 to 4 live streams or solving that part of the course. So thanks for staying to the end of the live stream. So if you also run into challenges like this, it's quite normal. You are going to run into a lot of errors on your code. So trying to figure out what is happening, what is wrong, and troubleshooting it is highly technical. And you have to be patient with yourself and give your time a couple of minutes to grasp and understand the error. You will eventually get it. I'll see you on day 27, which is tomorrow, as we continue on our pandas learning journey. Do have a wonderful rest of the day. Do well to support the channel by giving the video a thumbs up, hit that subscribe button, and I'll see you on the next video. Go watch the previous video. I'll see you there.